The next topic we're going to talk about is logic operators. Python has three main logic operators: the AND operator, the OR operator, and the NOT operator. They're honestly pretty intuitive in how they work, but there are a few little subtleties here and there that I will address. So for the AND operator, I'm just going to go through the formal definition of all of the execution rules for all of these. They might not make sense right now, but they will make sense once I go through some examples. So for the AND operator, the statement evaluates the first false sub-expression. Otherwise, it evaluates the last sub-expression. So what's the sub-expression? It's anytime you have expressions within expressions that evaluate to something themselves. Okay, so the OR operator is a little different in that it evaluates the first true sub-expression. Otherwise, it evaluates the last sub-expression. And then for the NOT operator, it evaluates the false if the expression is true. It evaluates the true if the expression is false. Pretty intuitive there. So let's look at examples of this. And I'm just going to run Python to show you some examples of this. So let's say I say true and false. Okay, so here I have two sub-expressions. My first sub-expression is true, and my second sub-expression is false. So what's the execution procedure on this? Well, we just make sure that it evaluates the first false sub-expression, otherwise it evaluates to the last sub-expression. Okay, so what's the first false sub-expression? It's false. Okay, and that actually happens to be the last sub-expression. Okay, so this should evaluate to false. Okay, and true and true, it'll evaluate to the, so it evaluates to the last sub-expression in this case because it's looking for the first false sub-expression. Okay, so I should probably put this over here so that this can be seen, although I can't really get that to work. But oh well, you guys get the idea. So true and true is going to return true, true, and let's see what else. True. What are the combinations? So if I have false and true, what is it going to do? It's going to evaluate the first false sub-expression. So the first false sub-expression is this. Is it going to even check true? No, because once you have a false and an AND, it's automatically going to be false. You know that for sure. Okay, and this is actually, I'm going to show you something really interesting in how this works. So let's say I have false and something that would cause an error. So 1 divided by 0, this would cause an error. But it's not going to error out because it's only going to look at false. It's going to find the first false sub-expression and then it's going to be done. So it's going to return false. Now, if I had false or 1 divided by 0, well, or looks at the first true sub-expression. So this is not a true sub-expression. So it's going to move on and it's going to try evaluate 1 divided by 0 and we're going to get a 0 division error. Okay, so the way to make this work out well is we can just do true or 1 divided by 0. Okay? Now, also an important thing to remember is that 0 is also a false value. So it's going to evaluate to the first, what is it going to evaluate to when we use AND? The first false sub-expression. Well, the first false sub-expression is 0, so it's going to evaluate to 0. So anything else is true sub-expression, so we can do it with numbers. So it's going to evaluate to the first false sub-expression in this case, and that's going to be 0. If I did OR, it's going to evaluate to the first true sub-expression. What's the first true sub-expression? 13. Okay, so everything in Python is true values implicitly except for 0, the empty string, and a few other things that we're going to look at later. So this is some examples of exactly how it works. And so if I do not 0, for example, I should get true, not false, true, not true, I'll get false. So this is examples of exactly how logic operators work. And I encourage you to do some very weird examples on these because there are some interesting examples of how they work. So let's look at a concrete example of exactly how logic operators work. So let's take this to the full screen. And okay, so I want to define a function. Actually, hold on. Before I go into this, there's one thing I actually forgot to mention. There's one more cool thing you can do in Python that we haven't really talked about. It's called default arguments. So let's say I want to, so I'm switching gears here because I realized I forgot to mention this. But so let's say I want to define the weight of something. So from physics, the weight of an object is just the mass times the acceleration of gravity. And the way we can do this, so of course we'll just first return the weight of an object, and so we know the formula, mass times g, which is acceleration of gravity. So g, acceleration of gravity. So it's good to be very precise in our doc string of what exactly is going on. And what we're going to do is we're going to have some examples. Weight of 10. So the acceleration of gravity is actually 9.8. So it'll return 98.0. And the reason there's a 0.0 is because 9.8 is a decimal value. So then we can also run the weight of 5. It should be 49.0. Okay, and the way we do this is we return mass times 9.8. Oops, 9.8. And this should work, so let's make sure our doc tests work for this one. So, yep. Okay, so cool. They work. Now let me propose a hypothetical question. Let's say for some reason we want to calculate a mass of an object on a different planet, which has a different gravitational acceleration. It would be kind of annoying to define functions weight for all of these, right? So I might have to do like weight Jupiter is equal for mass time and make it mass times like 12.0 or something, whatever the gravitational acceleration is. But now I'm going to show you a new feature of Python. It's called something called a default argument. And what we're going to do is we're going to pass in g, okay? And we're going to give it a set value of 9.8. Okay? So regardless of this, I can still pass everything in with one argument, and my doc test will still work because I have a default argument. I don't need to put anything in because it's default. It by default gets a value of 9.8. Okay, so now, but I can also handle the case where, I can put the weight width of like 10, and then a new gravitational constant of 12.0, and this should give me 120.0, and so I can run this, and it'll still work. And what happens is I basically overwrite the original gravitational constant. So this is a pretty cool feature of Python, and I encourage you to use it if you need to have any constants that once in a while might change. And this is also a very good way to abstract things. So this is not only to find the weight of things on Earth, it's to find the weight of anything across the entire universe. Alright, so where were we before I went on that tangent? We were talking about logic operators, and these were the execution rules. We went over these, and now I want to go over a concrete example of how exactly logic operators work. And to do that, I'm going to define a function middle. Okay, and what this middle function is going to do is it's going to take three numbers and find the middle value in the set of these three numbers. So let's write out docstring returns the middle value in a set of three numbers. Okay, and let's write out doc test. Middle of 3, 4, 5 should be 4. It can also be the case that we can have the middle be the leftmost term, 10 and like 10. So the middle of this is going to be -2, and the middle of this, let's make it 3 and -1. So -1 should be the middle here. So I've looked at so one good thing about test is even before you start, it forces you to think about how exactly you would write this function. So already I can see that I have three cases. One in which the b is the middle value, one in which the case where a is the middle value, and one in which the case that c is the middle value. Okay, and I'm not going to do test-driven development on this one. In test-driven development, I would test to make sure that the test fails, but of course I know that's going to happen, so I'm just going to go ahead and define my function. So what am I going to do first? I'm going to look at the case where b is the middle value. So if b is the middle value, it has to be the case that b is greater than a, and that b is less than c, or there's another case where b is less than a, and B is greater than C, right? Okay, and then in this case we return B. And then another case we have is the case with A is the middle value. So same pattern. We're going to check that A is greater than B, and then A is less than C, or A is less than B, and A is greater than C. Alright, and then we're going to return A. And then the last case is we just return C, because this tells us that we basically know that this is the last thing we have. Okay, so I think this will work, but in case it doesn't, I have tests to make sure that it will. So let's test it. It works. Alright, and remember, if you want to find a full summary of this, you can just do -v at the end. And so in this file we have 14 tests and they all passed. Alright, so let's look at a summary of exactly what we did. So the first thing we talked about was designing functions and the do's and don'ts of designing functions. Okay, and then the next thing we did is we talked about testing, and in tests we showed that tests are a great way to ensure correctness of code, and anytime you want to basically make sure the function runs the right way, you want to write tests. We also learned about the programming methodology of test-driven development and the process of that. And the last thing we learned about was logic operators, which were and, or, and not, the specific execution rules for this, and a practical example of how we would use it. So that's all I got for today. Thanks for watching. In the next lecture, before I go on into further material, I want to talk about how you would approach solving programming questions. And we're going to look at some simple examples, some not so simple examples, and two pretty challenging examples. So, and I'll go over how I would approach solving these, and also how you get, and also give a lot of takeaways on how to approach these type of problems. So, thanks for watching. I'll see you next time.